Thank you so much for the introduction. I'm Subeesh, and currently I'm scientist at Indian Council of Agriculture Research. And basically, I deal with precision farming technologies and developing systems and solutions for automating agriculture operations. So we'll discuss on accelerating agriculture, digital transformation, and smart farming through artificial intelligence. So basically, I'll start with some basics because there will be people from different backgrounds, and then I'll take you through some.
Sir,
Yes.
I'm sorry to interrupt, but if you're okay, you can turn off your video because we are facing a delay in your presentation. There's a network lag.
Okay, fine. Just wait 1 second. Can you turn off from your end? I'm just.
I'll check, sir. No, that option isn't for me. I could just mute you. I mean, the camera is just right next to the mic button and the share button.
Yeah, but not this system. We've moved to a different system.
Mute pin. No problem. So maybe we'll proceed, but then the slides aren't so clearly visible to us. So I thought you would.
1 second. Triangle.
Not clear. Yeah, it's better now, sir. The slides are good now. Yes, sir, we are good to go. You can start, sir.
Yes, fine. I have turned off. No,
Yeah, camera is off right now. Thank you, sir.
Okay. So I'll take you through some of the basics of data and image processing, and then we'll discuss some of the applications. So before we start, I just wanted to introduce why we need digitalization in agriculture. So according to Food and Agriculture Organization, the global population is set to reach 1.2 billion by 2050. So as we know that the global population is rising and we don't know that much of resources in terms of land, water and other resources, we are running short. So we need to rely on technology to efficiently make use of it. So the agriculture has to rely on technology driven solution to meet the ever growing demand. The agriculture has actually transformed through phases. Like in agriculture 1.0, if you take, it was based on we were very much leveraging on the animal power and using simple tools, and it was very labor intensive. So we have handheld tools, knives, and those kind of devices like small gadgets to do the agriculture operations. So when it comes to the agriculture 2.0, there was some synthetic pesticide, fertilizer, some better tools were introduced. And further it developed to 3.0 and we had the small mechanization started happening. We had the guiding systems, more tractors, sensor enabled systems, GPS based applications, all there were introduced. Now, when we talk about agriculture 4.0, it is the future farming technology where we drive greater efficiencies in farming using technology. So we have smart farming as a key focus area in this, and we use technology like IoT, cloud computing, and artificial intelligence. So the four aspect of this is more crop per drop. So we have to efficiently utilize the water, and we have to do data-driven solutions and continuous monitoring of the farm activities, and reducing the input in terms of fertilizers, water, or any other inputs that we will supply to the crop. So precision farming is again one of the core component of this. So precision farming is basically we are regulating what the definition says that precision farming is a technique of applying right amount of input in terms of fertilizer, pesticide, water at the right location at the right time to enhance production, decrease input, improve quality of product, and protect the environment. So environment aspect is also taken care in this because the overuse of pesticide fertilizers are creating so much of damage to the environment. So we need to protect. We have to regulate the supply, like input supply, we have to regulate. And we will supply exactly what is required for a crop. And recent advancement in technologies like IoT, cloud computing, big data analytics have made precision farming system more reliable and efficient. Now, when we start talking about data, so data is actually considered as a new oil. So data in 21st century is like oil in 18th century. It's a very valuable. So according to the Toby Watch, he's an Australian researcher. He has written in his book 2062, The World That AI Made. He has quoted like, if data is a new oil, then machine learning is the refinery of these large data sets. So we have to refine this data and take the meaningful insights from it. So machine learning will help us in this. And for those who understand and can extract value from it, and they'll be rewarded in future. So autonomous vehicles are getting popular, and we have new technologies are introduced day-to-day basis. So all these breakthroughs are possible only due to the data. Now we'll come to data-driven solutions. So how will you develop a complete end-to-end solutions in using data? So you must have heard about IoT, big data, AI. So I'll briefly give you the basics of all this. So IoT is basically will be collecting. It's a data collection unit, you can say, where the sensors are deployed on the field. Assume you want to get data from field, and you want to automate your irrigation or your water supply. You want to automate. So you'll be deploying some sensors in the field, right? There will be sensor node, and there will be a control unit. Let's say it can be Raspberry Pi or Arduino. Any control unit you'll be deploying on the field, and the sensors connected to it, sensors actuators will be connected to it. So let's say you have a temperature humidity sensor and water level sensor. So both sensors are integrated to the IoT, this control unit, and it will read the data. So that part will constitute the data collection unit. So assume you're collecting data every day. So that will have a huge amount of data will come from those devices. So that constitutes the big data concept. Like we have a huge amount of data, heterogeneous, all the properties, and you have to handle it with some extensive storage. So you may go for cloud or any other solutions. So we'll be capturing, we'll be storing, and we will be analyzing those data. So data analysis is important because there's a huge amount of data, and we need to get some insight from this. So for this, we have the AI-based solutions. AI machine learning can apply into this data, this aggregation of data, and we can make some insights. And based on that, we can make some decision. For a simple water level sensor or just irrigation purpose, we don't need a machine learning. We can just take a conditions or just simple if conditions, we can do that automation. But if assume you have multiple sensors, we are capturing so much of data. Let's say soil moisture sensor, we have different sensors and imaging sensors, cameras installed. So all these, when the data sets become huge, there we need complex analysis. So we may go for a deep learning, machine learning algorithm. So this is how the algorithm, once a decision is made, so you can again revert back to the actuators to do some operations. You can sense at the water level, and you can just you got to know that the water level is low, so you can directly irrigate. So you can turn on the motor. So for that, you can just give the control signal to the actuator and do the complete operation. So this is how you derive you come to a data-driven solution in agriculture. So the sensor, these are some of the aspect of it. Like you can have sensors installed on crops, livestock, greenhouse, farm machinery, storage. So in terms of crops, you can get the crop requirements, whether the water requirement or the stress conditions, the nutrient deficiencies, all this you can get from crops. And in terms of livestock, you can get what is any symptoms of the behavioral changes you can get, and any kind of diseases, outbreak of any diseases. They allow body attached sensors that can give you the information about how the like crop or cattle is, or sorry, the cattle or any kind of livestock is going through. And we have greenhouse where you need to control the temperature, humidity, all these values. So where also you can have the sensors. Further, we can have farm machinery tools like tractors are GPS enabled, sensor enabled, or they can automatically do the operations. And then again, the storage systems for post like shelf life assessment, and like storage temperature, ambient temperature is maintained or humidity is maintained. All these can be checked. So the data will go to the gateway. Going to the edge devices. So we are doing it in the edge, not in the cloud. So, but if the latency is not an issue, you can go with the cloud solutions, and where the AI ML model can be deployed, and it can give you the solutions, and you can give the notification. But maybe some people are from different domains, right? So I'll just introduce some of the concepts. So IoT is basically the network of physical objects that has embedded technology to communicate and sense, interact with their internal states or external environments. We have sensors deployed which can sense the internal and external things, in parameters, and which actually get this data and it can interact with the environment in terms of actuations. And Internet of Things is the integration of computer-based system with the physical world. So these are some of the IoT hardwares. We have Arduino, Raspberry Pi, BeagleBone, and for transmission we have XP module and ultrasonic HDHT11 sensor. There are so many lists is big, but I just kept only two sensors here. We have water level sensors and moisture, or there are different imaging devices. So these are the devices. So Raspberry Pi and Arduino are most commonly used because it is easy to handle. So for simple minimal applications, we go for Arduino, and for Raspberry Pi, if there is application is a little more complex, we go for Raspberry Pi. And even more extensive GPU-based system, we have to go for Jetson-based system. So if more of image-based solutions you want to build, Jetson will be a good option. And this is how you program the IoT devices. Like if it is Arduino, you can write your scripts in C, C++. It's just like more or less like say pin level, that you will be accessing the pins and you will be controlling like the passing signals to that. It's very simple. Many of you must have tried this. And in terms of when you talk about Raspberry Pi, we have a little more control on the GPI, more pins and more operations. And you can have the Python-based coding, so integrating models will be easy. You can even run your web-based applications, small web-based application inside. So it will give much more flexibility than Arduino. So that is also another option. And BeagleBond is again C++ supported. So this is how big data. Let's just introduce big data. So remember the days like we had when we started our schools and all that. We had the floppy disk. We had only 1.4 MB storage. So there was no concept of big data because the data itself was very small. So we never had a storage capacity that much. We had only very small storage capabilities, and the processing power. The system that time was like comes in like not even the powers that we have for our mobile these days. So it was like it was coming in 512 MB and 256. So this very less for processing power in terms of RAM and processing power. Intel Pentium processors. All this when I was doing my 10th standard. So those was so that there was no big data concept that time. So it was like the availability of data was the main thing, and the processing power and the storage capabilities. Increase in storage capabilities has gave rise to the big data. And now we have social media, every devices, sensors, all these are generating a lot of data. So this is again the concept of big data, and we have the 4Vs. We have 5Vs, 6Vs, but I just kept it very simple. So we have volume is the size of data, and variety is the different types of data, and veracity is the trustworthiness, and velocity talks about the speed and with which the data is generated. So all these concepts, whenever we talked what is IoT and now big data, these are all connected actually. Like it's you can say it's the two sides of the same coin. So each sensor pushes data in every second, so that constitutes the larger amount of data, and that again the IoT devices will generate this, and this will be like again analyzed. It need to be analyzed. This big data need to be analyzed with some kind of algorithms. You can go with AI-based algorithms can analyze this. So these are all connected. So if you add again blockchain to this, it will add the security part. So the technologies that is available nowadays, everything is connected. So machine learning, basically, you don't have to go for machine learning every time. So it's like, if it is simple, you keep it simple. Like if you don't have much features or much process to be done, so you can go with simple without much data processing. You can do the actuation or any operations. But the more features are more. If you have more sensors, it will go for a little more advanced analysis, and you have complex analysis if there are more like heterogeneous devices are there and so many other sources you are collecting data and analyzing. Then you can go for advanced ML analysis. So again, traditional image and versus big data analytics. So traditional analytics was mostly descriptive diagnosis analytics, and we have predictive analysis in big data analysis, and it talks about large data sets, complex data models, and it derives more meaningful insights. So again, AI, this I think I can skip this. You must already know. So AI is like again machines we are building, which we are imparting intelligence to the machines. So most of us will initially will be thinking like all AI-based systems are robots. So it's like we are knowingly or unknowingly we are part of AI solutions every day. So these are some of the examples. Like one example I can give you is like on the cardeko.com, which was I was recently browsing through. So they have this estimation, price estimation software solution. So in that, what they are doing, like if you want to sell your car, they will get your details like what is the model, what is the make, and how many kilometers you that has run, and what is the model. So all this it will capture, and it will calculate the estimated price that you can get. If you want to sell a second hand, so if you want to sell your car, you just have to enter all these details, and you can just check the valuation, and it will give you the price, estimated price. So in background, what it does is it has a database, let us data set of like last 20 years of sales data set, and from there we have built a regression model, and they kept it behind the application. So when you click this evaluate or get the valuation, so it actually triggers that model and give you the results. So similarly, Amazon have the book recommendations, and Google recommended this keyword search. All these are AI-based solutions. So this is basic again, like artificial intelligence, machine learning, deep learning. What is the difference? AI is a superset of all this, and with techniques enables machines to mimic human behavior. And when it comes to machine learning, it has again the subset of AI. We have statistical methods to enable machines to improve the experience. And when you talk about deep learning, it purely talks about neural networks. Okay, this is how machine learns. Again, we human, we learn from our experience. We are actually some of what we experience, what we read, what we listen, and what we see. So this is the input to the model as a human model. So similarly for machines, we can, just like we learn, we can also train the models to with different types of data and just make them intelligent. Like you can make them train, and finally we can evaluate them, and then we can deploy them to get some solution. Just like we think, the machine can also can get meaningful insights can be derived from the data trained. So these are some of the solutions, some of the algorithms we commonly we used: SVM, linear regression, k-nearest neighbors, ANN, k-means clustering, neighbor-based decision trees, XGBoost. So our list is big. Again, I kept a few algorithms here. So they learn from experience, like from the data set, it iteratively we train this, and we get the meaning out of it. Again, this is now this when you talk about agriculture applications, mostly we deal with computer vision these days. The extensive use of computer vision, machine learning also, but computer vision has broader scope in terms of automation. So the basic difference between human and computer, as you know, like we cannot do more complex mathematics, but computer can do. And we can remember images, or we can remember anyone, and we collect those information, visual informations for long time, but computer cannot do that. So that like integration of that particular vision capability to computers, that can really make them a powerful system. So this is was the concept behind computer vision and deep learning based computer vision. And even we are trying to mimic the complete operation of a brain using DL models. So we are quite successful using CNN, RNN, these kind of models. Okay, in agriculture, computer vision, again, this just talk. Uh, um, yeah, then the classification models, object detection models. So these are the main differences. The classification, it assigns a class to a complete image. So object detection can give you the localization as well. So it will localize like where exactly the object is. So this target, right, this identification of target or detection, this is very important. So assume you are doing a weed detection, and you're building a robot with weed detection. Let's say you're building with a ROS2 or some robotic platform, and you can integrate your deep learning model into that. So what it does is we'll assume you have a object detection algorithm where it can locate and coordinate. It can give you the like where the exact location of the weed. So you can do the targeted spraying. You can activate the sprayer unit and you can spray on that. So in that way, the weeds can be eliminated. So this is a very well-known example. So with, with object detection, this can be achieved. So this is the technology stack that generally when I work, I use all this technology stack. Not all, but these are some of the options. Like yes, I can learn for machine learning model building, TensorFlow for deep learning, TensorFlow Keras, and PyTorch. These days, PyTorch are being used extensively, and NumPy and Plotly. So visualization we use for Plotly, Matplotlib, and Seaborn. These three are used. And these are all for generally normal data sets like machine learning based applications. And you have now you don't have to worry for your GPU based system. Like you can go collab based model building. So where collab gives you extensive GPU capacity. Paperspace, AWS, Google AI, Azure, DigitalOcean, all these cloud options are also available. And you can convert your deep learning solution into you can integrate with mobile application using Flutter. Flutter again, this is something which you can explore. Flutter based applications are very like nowadays it is getting more popularity because it can run in both in your Android and iOS, just like React Native, but it's more easy. Flutter based applications, you can easily integrate your ML models. And again, Flask, this for web-based application, we have Flask, Python-based framework, Django, Rust framework, and for MongoDB, PostgreSQL. These are all for web-based if you want to build applications. Front end, you have HTML, CSS, JavaScript, jQuery, all this for front end language. So with this complete technology stack with plus your hardware, you can build strong solutions for, powerful solutions for agriculture-based applications. So these are some of the applications that we have developed. We had developed one plant disease identification system where you can capture leaves images, and then this is very common example that so much of solutions have already come in this area. This we started like I think 4 or 5 years back. Before I joined ICAR, it was there. So plant disease identification was one of the key areas that we were working, and we worked this for a soybean crop, and we come up with a handheld device and a mobile application also. So this can detect the diseases. Similarly, this application can be extended to nutrient deficiency stress identification using deep learning. So generally talking plant disease identification, you can do with UAV based. Now there is a larger discussion on the use of drones for spray. What disease, like if there is a pest or disease infected areas, the targeted spraying can be applied with drones. So UAV images or any kind of crop images, leaf images can be taken and can be done for classification of the detection or disease identification and detection. So this is one core application area. Another one is crop stress identification. So crop stress is actually basically refers to the adverse environment conditions that negatively impact plant growth and development. So you can say that temperature extremes, nutrient deficiencies, drought, or water stress. So we had extensively worked on something, the same area, and we have developed some devices for this. Again, irrigation automation. So irrigation is like another very common example in agriculture. Like you need to manually turn on irrigation every time. So you can automate it with using sensors, soil moisture, temperature, humidity sensors. And this actually doesn't need much of machine learning because it doesn't. But if you want to forecast and you can do the irrigation management, you can schedule it for future. Or if you're integrating image-based things, then that requires a machine learning or deep learning application. So especially when you have a drone mounted system, you want to and you want to irrigation scheduling for for the upcoming season something. So for a longer duration, if you want to do, then again there is use of deep learning and image analysis. Again, pest and weed control is another application area where, as I said, targeted spraying can be achieved. We use deep learning based models. Again, I'm not going to the architecture level because I just wanted to cover the application areas mainly because the architecture CNN itself is not just a simple CNN. You can use so much of fusion architectures or even transformers or any architectures. It's just covering the application areas now. So deep learning again CNNs and object detection model. These things, like another thing I wanted to tell is like if it is simple, you have to keep it simple. Like if you go for a very complex architecture, that also requires complex, like the inference time also may increase. So sometimes you want to go with a very light architectures, which even if you have to compromise on the accuracy, if it is giving a decent accuracy and it's a lightweight model, you have to go for that. Because in agriculture, what happens is the sensors will be mounted on hardwares like tractors or device which moves fast. So you need to give some faster responses. Or if you are building some sorters or grader, we actually worked on some sort. I'll come to that. So you need to make sure that the loss use lightweight architecture always. Test and weight control, again, this I just covered. So agribots, again, robot-based systems. And main thing here is that we have to, the delicacy should be there. Like it should not do any kind of issues to the, any kind of problems to the fruits or things when it picks. The handling should be very delicate. And picking crops also manual dexterity and delicate touch. Many fruits grows easily in the heat and leafy vegetable can turn. So this is also again the material. There are some different research is happening in ICAR itself for like soft material, like how to without much issues and how to like pluck the fruits or leafy vegetable, how to harvest. And most is advanced enough to handle that precision. So agri-tech companies are still working on this. Many of the companies have come up with harvesting robots and weeding robots. Another thing is the innovation in livestock farms. So we have automations in product innovations and process innovations. So in product innovations, we have milk processing equipments, preserving milk. These are other robotic milking. And process innovation, we have smart monitoring, so where you can locate where the cattle is present, a position location, and what is the activity, health monitoring, and the feeding or nutrition you can manage, and reproduction related. So this is an example of how livestock can be tracked or how various activities can be monitored using smart collars. So smart collars will actually will have different sensor combinations. So it has localization sensor, accelerometer, temperature, humidity. It is body attached sensor. It generally it is mounted across the neck. So it gets a complete activity of the cattle. So it reads the time of drinking, the feeding zone, the travel distance, resting, feeding, laying time, and body temperature. So once you get all these details, you can actually see the pattern. You can apply some machine learning. Either if it is, let's say you're doing a classification model, you can easily identify whether the cattle is sick or not. Or the pattern is maybe like you can see that when the cattle is sick, is going to sick, get sick, it will have a pattern, difference in pattern. Just like the feed intake or the travel pattern will be different. And its body temperature, obviously, if it is related to some issues like some kind of diseases, there will be rising body temperature also. So those can be can be easily captured using classification model, and you can actually give this an information to the owners. And disease identification, well-being, stress detection, and maintaining care life health of cattle can also be done using machine learning and deep learning models. And even the behavioral identification. Nowadays, uh, there are studies in ICR, livestock-related institutes, like where they have mounted cameras and just to see the behavior analysis. And that also very much successful. Like a deep learning based model can easily identify. You can find many papers and related to that also. How the behavioral changes happening based on, they have done video analytics in this to identify the diseases and stress identification. Again, yield estimation is accurate estimation of yield is very important because it actually gives for packing and storage capabilities. Like the farmers has to plan for their post harvest activities. For that, this is very important, yield estimation. So machine learning, you can do like crop yield estimation based historic, and nowadays computer vision is also used like for detection, drone based imaging, and then detection and counting. And even it's segmentation, you can get the size of the fruits as well, and you can calculate the complete yield from orchards. So basically computer vision is used for orchard based crops. So orchard, let's like apple or kiwi or like oranges, all this you can use uh, computer vision based approaches. Suzy? UAVs. Again, fruit vegetable grading. So basically, graders manual grading is very tedious task. You have to one by one. Still, there are villages people are doing manual grading. So this can be automated with some computer vision solutions. So we have developed one solution for this. Actually, this is an intelligent food grader which we developed. We are used a CNN model inside, so which can it's actually the inside we have deployed inside the machine, so which can actually get the surface characteristics, and based on that, it can do the sorting and grading. So this has already released, and like it has around 200 kg per hour capacity. So it has different packing lines. It takes the fruits and it based on the surface characteristics class. It's a simple classifier, simple model, but it was very efficiently it is doing the operation. So now in storage systems are actually like very much required, because some of the very large storage systems they cannot go inside and see the conditions what is happening inside. So for this we use IoT based system. Humidity, temperature, identification of toxic gases can also be done, and risk level can be predicted. If there is an outbreak on toxic gases or any kind of issues, it can be like monitored in real time using IoT system. We can deploy sensors. Okay, risk level prediction can be done, and even you can do the shelf life estimation. So this is a very critical aspect of a food product quality management. So where the shelf life can be estimated, and accurate prediction of precision support quality control, waste reduction, and enhance consumer satisfaction. And machine learning can actually do this. Like you can estimate the shelf life based on the historic data, and you can train the models and we can even do the vision based system. You can see whether it is going to spoil or not by mounting cameras on the storage spaces. There are other applications as well. Greenhouse management. AI and IoT sensors can closely monitor the greenhouse and give recommendations. And seed sowing help identify spaces best suited for sowing and what is the sowing pattern. And based on the geographical characteristics, it can give the recommendations. Soil analysis and classification. This is more of land and water related aspect. So where you can do the land classification, soil analysis, nutrient analysis, and agriculture, land use and cover mapping, all this. And basically there are endless applications in agriculture, and relatively these are compared to the other domains, it is less explored. So there is good scope for the research. And there are a lot of other examples also, even the supply chain management using blockchain and AI. So there are multiple set of applications. I've added some of them. And these are some of the publications and works that we have done. We have designed recently. This is the work I was talking about that we have done like sorting machine. So this was published in engineering application of AI and field robotics. We have a couple of publications in that. We have developed a robotic sprayer which actually goes in the greenhouse. It does the spray automatically. And we had the sugarcane dodging issue. We have addressed that issue using deep learning model. And again, shelf life prediction. It's a growing trend is observed in the last few years. From last 2 years, there is a spike in research articles, but there is in terms of patent and other copyright, again there is a lot of scope. You can build solutions with deep learning integrating into a hardware with Jetson or any Raspberry Pi, and then you can always go for a product based, I mean targeting to the real field, and you can deploy it in the field and see that like how it works. So there are good scope. You can have real solutions. In part, I mean agriculture is always open to do this.
Now, what I should ask him about information.
Hello.
Sir, I'm so sorry. I got a network issue and I got disconnected. But your screen is good to go.
Okay, are you able to hear me now?
Yeah, now it's all fine, sir. I got disconnected and I just rejoined.
Okay. So others have issues, or you want me to
No,
go back?
everyone is all fine. Only I had an issue. Everything is all fine, sir.
Okay, fine.
Yes, sir.
the research status. And some of the tools that I basically use, I use Word to the drafting, and Grammarly you can use for the quality improvement. And generally, I wanted to discuss some of the aspect of visualization basically. And reference management, maybe mostly you will be using mentally. And I use Zotero because it's kind of lightweight, I feel. And then data visualization, Origin Pro is a good tool for to go. And again, Python based visualizations are very good. You can go with Seaborn based visualization or Plotly. So these graphs looks really cool. So you can go with data visualization using Python, and even if in the minimal level, you can use Excel. And infographics basically for graphical abstract, uh, Adobe Illustrator and Photoshop Visio combination is good. And Draw.io for minimal graphs, and Max is also another option for infographics. So these tools are quite handy in researches. And again, this is a debatable topic. AI solutions are constructive or destructive. So yeah, artificial intelligence is a fundamental risk to the extent. This is what Elon Musk has quoted. But it's like it is always not the gun that kills; it's the person behind the trigger who takes a life. So it means that it's upon you, like how ethically you use the solutions. We are like nowadays we are getting so much of solutions. It's with the last 6-7 months there are a lot of improvement in the technology area. Like we have a lot of solutions coming up with the DeFi technology, social manipulations, a lot of things are happening. So again, it is you have to be responsible in developing solutions. And with that, I am just concluding. It's a traditional pattern of agriculture is again redefining using AI. So automation agriculture can be achieved extensively using AI. And again, there are significant research opportunities, and you are always free to welcome, like feel free to explore all these opportunities. And with that, I conclude here. Thank you so much. Hello.
Yes. Okay. Fine. Thank you so much, sir. But before that, let me give an opportunity to participants to ask any queries. Dr. Harish, I'm allowing the mic for you, so you may please unmute yourself and ask the query.
Yes, madam. Sir,
Yes, yes.
am I audible? Sir,
Yes, yes.
some researchers are working on the butterfly classification, computer vision based butterfly classification. And I want to know
Okay.
what is the significance of the butterfly the automatic butterfly classification using computer vision techniques. What is the significance of the classification itself in the agriculture?
See, classification, I should go for, see, in terms of if you are taking go butterflies, in terms of pollination, it can help. But
Yes, sir.
more of classification, I suggest you go for, if you want to build it as an automation solution, always better than classification, you go for object detections. So that you can
Okay.
target it. Any objects or anything you can target. Just like if you take
Okay.
a weed or any kind of flower, fruit, anything, if you can target, you can apply, right? Anything. Let's say you want to spray, you can actually target the object, not the complete. Like if you tend
Yes.
to class it, complete classes, you will give a one class, but you don't know where the location, right? So it
Okay.
always go for object detection, but it depends on like butterfly classification. Maybe it's for species related. Say some people will be working on the species, like what kind of
Yes,
species
sir.
they have to do. Maybe because of that, it may help in one or the other way because agriculture is broad, right? There are
Yes,
scientists
sir.
with species related aspects also. So
Okay, sir. Thank you, sir.
no issues with the classification, but if you want to build it as an automation solution, it's always better to go for object detection.
Okay, sir. Thank you, sir.
Any more queries from participants? Kindly raise your hand and I'll unmute you. Okay, Subeesh has experience with a very good organization, as you might all know. So he's a scientist, and it's a good opportunity for all of us to clarify whatever queries we have. So I request you all to open up if you have any queries, please.
So if you have any questions, you can always write to me also. I have given my email ID and you can reach to me if you have any issues.
Okay, so as I was saying, like we'll pass out all the speaker details along with the mail IDs. So at any point of time, you may contact them. Okay, so I take that as no query. So with that, I would like to thank Subeesh sir for taking a wonderful session. Like we are all I mean, like even before the PhD began, you have so many good publications and you've got such a vast exposure with a very big organization. I'm really so proud of that. So thank you so much, Dr. Subeesh sir, for handling this wonderful session for us. Okay, fine. So tomorrow we have another 2 sessions.